Hello, good morning, students. Okay, we're going to look at this particular question, convolution code. Having done other means of error correction, we want to look at convolution code because most of us were not around when we treated it. So what do we mean by this convolution code? Convolution code is just a type of forward error correction code. That in a short term, FEC. We know that in linear block code, the output normally depends on present k-bit inputs. But in this convolution code, the output depends not only on k-bits, but also in the previous m bits, that's message bits. Now, let's look at one of the examples because I won't start going back from the beginning because of time. Let's look at this question I gave you, the tutorial question I gave you. Say that a convolution code has shift resistor with 2 stages and 3 module 2 address with an output multiplexer. And you are given that the input message to be 1011. You are asked to determine I, convolution code word length. Now, how do you calculate this convolution code word length? We have that our convolution code word length is equals to n bracket L plus M. Now, what is this L? We are given that our data, our message code to be 1011. So the length of the input data given to us is how many? 1, 2, 3, 4. That means our L is 4. Then the number of encoded output bits, that's the output we are going to get, we are given that we have a module 2 addresses. So we have 2 to be our n, while our m is constraint length. What do you mean by constraint length? We are given that our message is m0. Then we are given 2 messages, m1, the constraint to be m1 and m2. So we have how many constraint lengths here? We have we call it safe resistors to be 1, 2, 3. So we have 3. When you add 4 plus 3, it will give you 7, plus the number of outputs which we are going to get. We are going to get x1 and x2. So we have 2, which is 2 times 7 will give you 14. So the number of code words we are going to get, or code word length we are going to get, will be 14 bits. Okay. Now, the next question we are asked to calculate is the rate. We have a formula for this. We are given that code rate denoted with small r is equals to k over n, where our k is the number of message bits. When we'll be given a message bits, we are going to have, sometimes they will draw this for you in the exam. Sometimes they will not give you, they'll give you that M0, which is only 1 message bit. And what is being fed inside there is 1011. Is that clear? And we're asked to look for M1 and M2. That means the number of message bits we have here is only 1 bit. So we're going to have our rate to be 1 over n. And we have that our n, which we use in calculating, to be 2. That means our code rate will be half. Okay. The next thing we are asked to calculate is the code state. How do we calculate this code state? First of all, let's look at the dimension of the code we are going to have. We are going to have 2 outputs, which is x, y, and x2. Then we have only 1 input bit. That means the code dimension is going to be nk. That is how our dimension is going to be, which is 2, then 1. The output and the input. Assuming you are asked to state the code dimension. Okay, now let's look at how to calculate our code states. Using this diagram I drew before, let me repeat it here. As I said earlier, they might give it to you, or they might not give it to you. Like the one I have here, it wasn't given to us. Now, normally, in this code state, for you to draw the decoder, they will tell you whether it is linked or not. From this diagram given to us, we have that M1, that's the message, the current message, M1 and M2 that are linked together to give us X1, that's output 1. Then we equally have our M0 and M2 to link together to give us the modulo. Remember, we are told that we have modulo 2. So we have the one modulo and one modulo. So we're going to have X2 as the output. These are outputs. That means this output will be swinging between 1 and 2. It can move to 1 and come down at 2, move to 1 and come down at 2. That means we're going to have our encoded sequence to be between X1 and X2, X1, X2, and so on and so forth. Is that clear? Remember, I told you that our MO is the current message, while your M1 and M2 is the state convolution code. You call it state convolution code. Okay, done. And this plus that is being circled is known as modulo. Okay, then before we start calculating the code state, let's first of all know the number of code states we are going to have. How do you know the number and where to stop? You use the formula, the number of code states to be 2 raised to power capital N minus 1. Where your N, capital N, is the number of memory elements. Number of memory elements, which is M1, M0, M1, and M2. So when you put it there, which is minus 1, you're going to get 2 raised to power 2, which is 4. That means you're going to get 4 states. Okay, let's do it. You have M0, you have M1. Okay, let's M2 because it's state they asked us to. We are not using the current state. Then let's look at the states that are going to be. Okay. Now, we assume that this is 0, 1, 0, 1. I'll have 0, 0, 1, 1. Now, we are going to assign any states from A. Whenever we see 0, 0, we assign A. Whenever we see 0, 1, we assign B. Whenever we see 1, 0, we are going to assign C. And whenever we see 1, 1, we are going to assign our letter D. That is what we are going to use in solving. Okay. Now, the next thing we are going to get is to get these code states. Now, we are going to start from the input given to us. Remember, we are being fed with this input 1, 0, 1, 0. Now, before we start, we are going to assume that the initial states of your MO, M1, M2, and state will be 0, 0. And I don't like using diagram to denote it because of the. If you like, you can use diagram. If you like, you can just write it like this: 0, 0, 0. Okay, I have my 0, 0, 0, which my M1, M0, M1, and M2. Now, feeding my inputs there. Now, the secret of this convolution code, remember, I told you that it's moved between x1 and x2. Now this is the first one. We assume that we are starting from this last one. That is what we are going to start from. Now we're going to put in that one. Look at that one. I'm putting that one here. So I have 1, and then I'm left with this 0, 0. I'll put 0, 0. Now, in convolution, the first one, remember I'm moving from x1, x2. So it moved from this one to this one. Then this one will move to this one. It moves like this. So when 1 moves to this 0, the 0 will move to 0. So let's take it. This one will move here. I'll have 1. This 0 will move here. I'll have 0. The other 0 is off. Then I'll now go to the next input given to us, which is 1. Will now enter here. Then I'll continue. Okay. Now this 1 will move here. It will now be 1. This one will move here, 1. This 0 will move out. Then I'll go to the next input, which is 0. I hope you are following. Then I'll assign again. This 0 will move to the center. This one will move here. This one will move up. The next one that is remaining is this one. I'll now put this one. So I'm going to have 0, 1, 0, 1. Okay, I will continue. Okay, let's say this one will now enter here. I'll have 1. The 0 will go to the other side. The 1 will disappear. Then we are going to the initial state. Remember, we started with 0, 0. I'll assign 0 here. I want to get a situation where I'm going to get back my 0, 0. So this 0 will move here. The 1 will move here. This 0 will go out. I'll have put 0 here. I'll continue. Now this 0 will move here. This 0 will move here. The 1 will go out, and I have my 0. You can see that I've gotten back my 0. I started from 0 and I've gotten down my 0. Now the next thing I'm going to do is to calculate the output, because it is this output we have already gotten our M1 and M2. So let me bring it out in table. We have a M1, M2. So the first thing I assigned was 0, 0. Now this is 0, 0, 0, and I have my 1, 0, 0. I have my 1, 1, 0. I have 0, 1, 1. I have 1, 0, 1. I have 0, 1, 0, 0, 0, 1. And I have 0, 0, 0. I'm cancelling that one because I'm not using it again. Now, if you go to what we had before, let's look at the current state. Then the next state, then our output 1 and output 2. Okay, let me do it like this. Now remember what we said before. Any place you have 0, 0. If you have 0, 0, we're going to have a. So this is my current state. Then, which is equal to the same thing, my current state is A. Okay, now the next state will now be what? 1, 0. 1, 0. My 1, 0, let's start from the beginning. I had 0, 0 before, which is just 0, 0. So let's assume that all these ones are 0, 0. Now I now have that my current state to be A. The next one is 1, 0. And from my 1, 0, I had my next state to be C. Then the next one is 1, 1. If the next state is C, I'll bring that C here, which is now the current state. So the next one is 1, 1, which will be D. I bring that D, which is now my current state. My next state will now be 0, 1, which is B. I bring that my B here. So my next state will now be 1, 0, which is C. I bring that my C here. And the next state will now be 0, 1, which is B. I bring that my B. And the next one is 0, 0. So I'm back to my A. So let's look at the outputs. Remember our binary addition, definitely 0, 0. Yeah, will be 0 because 0 plus 0. Now, there's something we're going to do which is very, very important for us to calculate our output. We're going back to this diagram. If you look at this diagram, for us to get x1, we have m0 modulo m1 modulo m2. They are all added together. While our x2 is only m0 and m0 modulo m2. So that is what I'm going to use in doing this calculation. Okay, let's look at it again. Excuse me, please. Okay, now we're going to use that formula to calculate our x1. So if you look at our x1 here, we have our x1 is m0, which is 1, plus m1, 0, plus m2, 0. So 1 plus 0 plus 0 will give us 1. Then m2 is m0 and m2, which is 1 plus 0 will give us 1. Okay, this x1, 1 plus 1 plus 0 will give us 0. And 1 plus 0 will give us 1. 0 plus 1 plus 1 will give us 0. 0 plus 1 will give us 1. 1 plus 0 plus 1 will give us 0. Then 1 plus 1 will equally give us 0. 0 plus 1 plus 0 will give us 1. And 0 plus 0 will give us 0. 0 plus 0 plus 1 will give us 1. And 0 plus 1 will give us 1. So I have calculated our output. Now, we're going to use this output to draw our code, our 3 code. Now, how do I draw my 3 code? To draw this 3 code, we're going to use a particular law that says that down step means 1. Looking at our input, if you have 1 at the input, that means we're going to draw a line down as if you're moving downstairs. If you have the input to be 0, we're going to draw it to be up. So this our input. If our input is equals to 1, it goes down. But when the input is equals to 0, it goes up. So let's look at it. Now, what and what are involved in our code 3? Each code branch of the tree will always represent an input symbol with the corresponding pair of output binary symbol indicating on the branch. Now, looking at this diagram or at this table, now let's draw our code tree. We're going to assume, remember I told you that we normally assume to start at 0 state. So we have our 0 state to be 0. And if it's 0, our 0, 0 will give you A. So we are still at state A, while the output is 0 0. Then the next one is 1. The input is 1. Let me underline it so that you will know the one we are doing. Okay, so the next one we're going to look at is 1. So since it's 1, it goes down. And once it goes down, the output is what? 1 1. You write 1 1. And the next state we're going to move is C. So we're going to put C at this place. Okay, let me draw it in a place where you'll be seeing very well. Remember, we started with A, which is A is 0 0. It's moved down. The output is 1 1. The next step there is C. Okay, now another input here is 1. So we're still going down, showing your arrow. Our output is 0 1. So have as 0 1. And the next state there is D. So we're going to put our D here. You see that you write it like this, or you write it D output. Sorry, output is 0 1, not 0 0. Okay, then the next one is 0. So it goes up. It goes up. The next one is 0. It goes up. And the output is 0 1, which is 0 1. The next state is B. You continue. The next one is 1. It goes down. The output is 0 0. While the next step is C until finish. So that's how to solve our convolution. Thank you. We're still going to look at how to solve other errors.